an analytical exploration into human longevity frameworks valid in 2026, mapping out soft robotics, bioprinting, and remote haptic medical infrastructures. Soft-Robotic Mobility Exoskeleton core aging is not a biological certainty. In 2026, we view it exactly as it is, a simple engineering failure of a complex system. Until now, muscle degradation and joint wear meant one inevitable thing: the loss of autonomy. But what happens when you refuse to rely solely on the limitations of flesh? The future is soft robotics. We are talking about intelligent textile suits with integrated, flexible artificial muscles. They are so light, you can wear them under your everyday clothes. The secret lies in real-time telemetry. The suit is equipped with hypersensitive myoelectric sensors that read the electrical impulses traveling from your brain to your muscles. It literally reads your intent before your physical muscle even contracts. In less than a millisecond, the internal processor calculates the exact force deficit, the gap between what your tired muscle can do and what the movement requires, and fires the elastomeric actuators. It's not a machine carrying a passenger, it's a direct extension of your nervous system. Metabolic lenses and biomarkers. Health isn't a guessing game anymore. In 2026, waiting for symptoms to appear before treating a disease is an outdated, failing strategy. Standard blood tests only show a single static moment in time. Meanwhile, silent inflammation, oxidative stress, and metabolic shifts are damaging your cells completely undetected. To stop biological decay, we need a continuous, non-invasive radar. Enter metabolic lenses. We are moving past traditional wearables into bio-integrated smart optics that read your chemistry in real time. The secret is microfluidic analysis. These lenses continuously sample your tear film, tracking fluctuating glucose levels, lactate, and specific longevity biomarkers without a single drop of blood. An embedded microantenna transmits this raw data to your localized AI health dashboard. It instantly cross-references your real-time chemistry with your baseline metrics, intercepting metabolic failure before it manifests. Polygenic risk tracking. Your DNA is no longer a fixed script. In 2026, looking at single gene mutations is a primitive way to predict your future health. Most chronic diseases aren't caused by one broken gene. Cardiovascular decay, cognitive decline, and metabolic failure are driven by thousands of tiny genetic variants working together in secret. To intercept decay before it begins, we need a macro lens for our genome. Enter polygenic risk tracking. We are aggregating millions of subtle genetic variations into a single, highly accurate predictive score. The power lies in advanced genomic algorithms. By analyzing your entire genetic architecture, we can calculate your precise statistical vulnerability to complex diseases decades before the first cellular symptom occurs. This score integrates with your real-time biomarker dashboard. By matching your genetic vulnerabilities with hyper-targeted lifestyle, medical, and environmental interventions, you can literally turn down the expression of bad genes, rewriting your health outcomes at a cellular level. Remote haptic surgery frameworks. Geography is no longer a death sentence. In 2026, waiting hours for a specialist surgeon to arrive at a local hospital is a flaw we can finally eliminate. When internal organs face critical failure, every second matters. Traditional remote surgery was impossible because even a millisecond of network lag could cause a catastrophic, fatal error. To solve structural decay globally, we needed a breakthrough in tactile networking. Enter remote haptic surgery frameworks. We are combining ultra-low latency 5G slices with advanced force feedback robotics. The secret is kinesthetic data streaming. These haptic gloves don't just move the robot, they send the exact physical resistance of the patient's internal tissue back to the surgeon's hands in real time. Operating on high-frequency, dedicated medical networks, a top-tier surgeon can guide a mechanical arm across continents with sub-millimeter precision. It bridges human expertise with robotic stability, operating anywhere on Earth with zero physical friction. Bioprinting vascular networks. Organ failure is about to become obsolete. In 2026, the biggest bottleneck in regenerative medicine isn't printing cells, it's keeping them alive. We've been able to print basic human tissue for years, but without a functional blood supply, thick engineered tissues and synthetic organs suffocate and die within hours. To defeat organ decay, we had to master microscopic plumbing, enter bioprinted vascular networks. We are now manufacturing high-resolution hollow blood vessels embedded directly inside living matrices. The secret relies on sacrificial bioinks. The printer lays down a temporary, temperature-sensitive hydrogel framework. Once endothelial cells are cast around it, the ink is flushed away, leaving perfect hollow channels. These printed microvessels integrate perfectly with a patient's host tissue, allowing blood to pump nutrients and oxygen deep into engineered structures. This is the foundation for fully printed, functional human organs, replacing worn-out biological structures completely on demand. Follow LumixHQ for your daily dose of positive news.